Right. So Kubernetes, right? So yesterday we were primarily doing the fundamentals of it. What are nodes? What is Kubernetes? How it works on top of these nodes? What are pods? What are services? How we expose services? So we expose services by node port, load balancer, port forwards, or ingress out of this load balancer, and using an ingress settings are what the enterprise uses. And the real use case of this is primarily the load balancer. And this, there of course there can be more ways of doing this, maybe some sort of API gateways and this and that. But to expose a service which is present inside a cluster, to expose it to the outside world in the sense to the internet, you need something like this. Otherwise, everything will be within it. And if you have an application where it has multiple components, a lot of microservices, and these services need not be exposed. So a lot of services, actually more than 90% services or components of an application need not be exposed at all. Only few, 2 or 3 are actually client-facing interfaces. Like your front end is a client-facing interface, right? So you only expose that, and the other services remain inside, internal, and cannot be accessed from outside, but can be accessed from within the cluster, within the Kubernetes cluster. So one service can access other, this can access other, this one. How can they access? To access any service, you need to have an address, and that address is actually the IP address. An IP address has been, by Kubernetes, it's been assigned a name in the form of a service name. And using that service name, one service can find another service very easily without having to remember any IP address or anything. The IP address can change eventually if you restart the service, maybe IP of that can change, but the service name remains. And under one service can route traffic to multiple pods, and inside multiple pods, you run containers. Containers run on a Docker runtime environment, which is present already there by Kubernetes. Kubernetes already took care of something called as Docker runtime, a similar environment, which your Docker desktop also gives you. Your local Docker installation also gives you. That's called as Docker runtime. Docker runtime means a software, a system which can run your Docker image and convert from Docker image to a Docker container. That's what Docker runtime is, right? So there are different services. This is what basically we discussed, how one service called another service and how all these things really work. This is what we did, and this is called as container orchestration, right? So Kubernetes is a software which provides container orchestration. That is a place where container runs efficiently with all the communication and networking problems solved and all those things. This is what we did earlier before Kubernetes came into picture. So let's say this is a traditional way, and now we are trying to move from this to here. So now we would like to run our Flask API, which we ran here on an EC2 node. We install Docker installation on top of it. This is Docker installation is actually the Docker runtime. Let's call this a Docker runtime. And on top of it, we were running Flask API. And we were doing actually one more thing. If you have done all the assignments which I gave you, we have done one more thing on top of it, which was actually Nginx server. And our user was actually communicating on Nginx server, and then Nginx server was rerouting traffic to Flask API. So this is how it was all working, and this was everything was happening inside an EC2 instance. So I'm just doing a quick recap of what we were doing earlier, okay? So this is what we were doing. Everything was running on top of EC2 instance, a Docker runtime on top of it, and yeah, so that's how it was working. I also explained the concept of load balancer here. Load balancer here is an interface which has an IP, which is available on cloud network. And when you want to have 3 machines or maybe 4 machines trying to connect or having similar setup, a load balancer comes handy here, where the load balancer, so the front client it can be browser, can be another machine. They can try to reach out to load balancer, and load balancer then can distribute the traffic among different machines. So that is the idea of load balancer. The same idea of load balancer or similar to that is applied by services. The services act as a load balancer, a sort of load balancer where it has a power or capability to distribute the traffic based on different number of nodes. Why would someone wants different more pods? Because if there is a more pressure on it, in the sense there is more traffic coming in here, and maybe one pod may not be able to handle all. So this is how it scales. It can create multiple replicas of the same application. So one request comes here, second request comes here, and then third request comes here. So it divides. So now you can handle double the load. So let's say there were 100 users coming in and one pod was not able to handle. Now you have two pods. So 50 requests goes here, 50 requests goes here. What if there is 200 requests? You spin up quickly four more pods. So now all those will go to 50 each. So now you can handle 200 load. So that's how you scale, right? So you scale horizontally within it. The same way horizontal scaling was happening here, right? But in this case, you will have to spin up the whole machine and add it under load balancer. Now instead of doing this kind of thing, you can very quickly and easily can do that under services. Okay, so this is basically what we discussed yesterday. Any questions in this diagram? Okay, then we had these pods, sorry, with these nodes. This is how the setup works. You have cluster, inside cluster you have nodes, and then your pod runs on different nodes. So node 1 running one pod, node 2 running two pods. They can be the same pod running. So let's say the replica of this pod is 3, one pod running on node 1, two pod running on node 2. This is something which Kubernetes manages internally, so you don't have to worry about it. So based on different machine power, it allocates nodes. So this is also one of the Kubernetes configuration when you set it up. You can do these things, but right now we are not looking into Kubernetes installation. We are not talking about Kubernetes installation. We are not learning that at the moment. We are learning how to use a Kubernetes cluster. We are not learning how to deploy a Kubernetes cluster. We are learning how to use a Kubernetes cluster and how you deploy an application on top of Kubernetes cluster, right? So understand the difference. Don't get too confused. We are not learning Kubernetes installation. We are learning how to deploy an image or how to run applications on Kubernetes cluster. So to say, that means how to use a Kubernetes cluster. That's what we are focusing on. Okay. So how this two diagrams actually are talking about how the external client can reach the your service, right? So there are different ways available. One is node port, second is load balancer. These are two primarily being used. Not primarily, actually, load balancer is something which primarily is being used. Other than that, there's ingress settings which can also be used, which we'll talk about later. Okay, if there is no question, then what we are going to do today is to do some hands-on. So when I say hands-on, hands-on here mean that we will try to deploy some application, a simple application, onto our cluster, onto our minikube cluster, and we will see some basic kubectl commands. So when I say hands-on, it's the command line interface of Kubernetes, which is run by kubectl, and that's what we will try to learn on what are the different commands we have. How do we access cluster? How do we get to see services? What's running inside? How to see the containers? How to see the logs? How to delete? How to update? And all those things. So that is something which we will try to learn today. Okay. Okay, to start with, as I said, if you want to learn Kubernetes, or if you want to try or want to use Kubernetes in a dev environment, then you have three options, right? So we talked about three options which you can try. One option, let me note it down here. Okay, so one option is called as minikube. There is second option, which is why this is happening. I am copying the whole thing. Fine, paste. Oh, I don't know. Never mind. Let me do it again. So then second is kind. This is called as Kubernetes in Docker. That's another way of running Kubernetes on your Docker environment. And the third, I don't know. Okay, then third is micro K8s. Okay, this is third one. So there are three options you have which you can try. This works very well with Linux systems. So micro K8s, let me show you quickly. I'm telling you these options because sometimes one option doesn't work for someone, so you can try it with the other one. So this is lightweight Kubernetes, zero ops, pure upstream, HA, Kubernetes from developer production to work production. So this is something which you can try. This is managed by, I think, Ubuntu systems or Linux systems. I think I actually have never used it, but it's quite famous. So this is something which you can use. Second, you can use is kind cluster. Right, so this is kind Kubernetes, which you can use. This I have used extensively. I used to use it for a lot of my other experiments or other things which I work on. This is quite good. This gives you an ability to create a multi-node cluster. Which sometimes you may want to have a look at because the minikube doesn't give you this setup where you have two nodes. Minikube gives you only one node and everything runs on one node, which is fine for learning purposes. There's nothing to there. But when you when you want to look at cases where you want to see a multi-node cluster, you want to work with a multi-node cluster, then on that to onto your local system or development environment, then kind is your answer. You try to see how you can make use of kind in those cases. Okay, so you have three things which you can try: minikube, kind, and Docker. Out of all this, minikube is supposed to be the easiest because it comes directly with Docker desktop. And to start with it, it's quite easy. Let me quickly come here. Okay, so I say minikube and I say status. This is something which we discussed last time also. Let me make it a bit bigger. Okay, so it's running right now. I want to stop it. I say minikube stop, minikube. And if you don't not getting the command, just press H, minikube H, and this should give you the all the details of what are the commands you have here which you can run. Okay, so start, status, stop, delete, dashboard. Delete you don't use too much. You use it only if, I mean, you can use it. It's not that big a problem. It will delete all the configurations. So you may have to do a few things again. But when there is some error which you're not able to understand, which is coming from minikube start, when you run minikube start, if you're getting error, try deleting it first and then try. Okay, so I'll say minikube stop, it stops. I say minikube start, so it starts. So then you say minikube start, and then you say minikube status. Then it will tell you that's running. So you want to see these things before you start working on it. Okay, cool. Now once you have minikube, now if you guys don't have this on local machine, I can't really help you with that. So you have to go to your EC2 instance, and EC2 instance you may have to find a way to install minikube there, which I think should be there. You can try having a look. If it doesn't work, then let me know. I'll give it a try at my end to make sure that it works on EC2. Maybe I'll create a Terraform script to spin up an EC2 instance, and then minikube is already installed there. Maybe I'll do that so that you don't have to install it on your own, and you just run that Terraform script on your machine, and then you'll get an environment where you can play around with minikube on your EC2 cluster. So I'll try to do that. But so all in all, I'm going to use minikube a lot while we do this, and then we will try to see how this works on an actual cluster later on. All right, first command I run. So once you have minikube status, the first command I would go and try to run is, I'll say, so minikube is okay, fine, minikube is done. Then I'll say kubectl thing. So kubectl or kubectl is called sometimes, is a command line interface to access the Kubernetes itself. So Kubernetes provides an API, and that API takes request from the user, which is us, the client, which is us, and execute things inside the cluster, right? So it has something similar to get, post, put, delete, right? It doesn't use those words, but instead of that, you use create, update, delete, get, right? These kind of commands or these kind of verbs it uses with different kind of parameters, right? So kubectl doesn't come automatically. You will have to go install that as well. If you're on your local machine, try installing it. It's not that big a deal. If you have Windows, Mac, Linux, you can do that. For EC2 instance, I will write a Terraform script. I think I will write that and I will pre-install that. So you will see the script how I'm installing it there. And then you will have a fully functional working EC2 machine with kubectl minikube installed there. Okay, so once you have kubectl also installed, the first command basically you run something like this. So I'm saying kubectl get pods. It's telling me that these are the pods which it is running. Okay, what are these pods? We did just discuss that, right? So if can I make it big? Can I share my screen like this? Huh. Okay, so you see pods. So what I'm saying when I'm saying kubectl get pods, I'm trying to access this pod. So this is telling me that currently Kubernetes is running these many pods. Okay, fine. Now, before I even run this command, let's start from the very basic. Okay, I'll today start with something called as namespaces. Okay, so I'll say namespace. What is a namespace? Can anyone tell me what is a namespace?
Namespace is a logical isolation of resources in
Okay,
Kubernetes.
Good. So when you have Kubernetes, right now, earlier what I told you guys was that you have nodes, then on top of it you have Docker containers. Sorry, you have Kubernetes installation, and then the pods are running, right? This I told you for the sake of simplicity, but there is also one more concept here, which is called as namespace. Okay, so namespace, as Neha, you told this, or?
Yes.
Okay, as Neha told us, it is a logical isolation between different segments. So you can create segments within the cluster itself. Okay. My God, I don't know why it's not copying and pasting. Copy, paste. Something is broken. Okay, fine. I'll create another diagram. Okay, so you have namespace, namespace 1, namespace 2, something like this. Okay, and then these resources, let's call them resources like pods, right? Pods, and resources like sorry, another pod, and then you have let's say service, right? They all live inside a namespace. Okay, so namespace is a logical isolation. So one pod is here, second pod is here, and then you have service here, and the same services you have there, right? Here you have another service, another kind of thing installed here, something like that. Okay, now another question. Can anyone tell me if I have a pod here, I have a service here, can this service access this service?
Yes, sir.
Yes.
No.
Okay. No. Okay. So answer is yes and no both. It is something to be configured. So if I want a situation where I have different namespaces, but I want the services to be accessible, I can still make it accessible. But if I want to control it, I will place some rules in that namespace so that it's completely isolated and no one can by mistake, no one can do it. I can even provide RBAC, role-based access control mechanism, where I say this user, if it has this role or this access, then it can access, otherwise it cannot. So all these possibilities are there, but we'll not go into those details at the moment. Just understand this. What can be the possible use cases here? Let's say you have an application and you want to develop and you want to have different environments set up within the same Kubernetes cluster. So I say this is a namespace, which is a dev environment. This is a namestage, which is a UAT environment. So my application, which is currently in dev state, will run here. My application, which is in UAT stage, then can go and run here. So this is just one of the use case of why these isolation or these categorization, segregation of different spaces within the same Kubernetes cluster is required. So this feature is also there in Kubernetes, and that is actually the fundamental thing. So if I go, I say k get name spaces, I get these many namespaces which I have. So I have something called argocd. I have default. I have ingress nginx. I have kube node lease. I have kube public. I have kube system. I have Kubernetes dashboard. So I have these many. So basically, 1, 2, and 3 default, kube system, and kube public. They are the one which is, or even kube node lease. They're the one which are the default namespace which Kubernetes has. So you shouldn't do anything inside this and this until you're really sure what you're doing. Right? This is where the Kubernetes stored its own stuff, basically, its own APIs and its own resources. So you shouldn't tinker with these. But by default, you can always use the default because name is default. So usually when you don't specify any namespaces, it's always automatically runs on default. Okay, but you can go ahead and create your own namespaces. I say k. Okay, by the way, this k, the command is actually kubectl. Okay, I am using k because I have configured it in my bash profile that I'll show you quickly, because kubectl, you keep on typing, it's a pain. So you can set something called as aliases in your shell scripts, right? So I'm using zsh, and it looks like, if I go open, okay, where is that? Okay, this is the file. Okay, so this is the file. This is under my user profile. If you're Windows, you should see this under C users, and then name, and then under that you will see that. So I have put something like this here, alias k kubectl. So this means when I say k, my shell will understand it as kubectl, right? If you want to shorten it, you can do that also. I'm using this under .zshrc because that's a shell I'm using. If you're using bash, then you can do that in your bash profile, which is this one. So you can do that something like this. I mean, I have done it here in the bash, but you can do same line here, and it will start identifying it. Okay, so I will be using k a lot. Don't get confused. If you just use k without configuring it, you will get an error. Okay, you can check which shell you are using, like this. It's telling me I am here. Okay, so if you're using bash one, then you can set it in the .bash underscore profile, and it should work. Okay, now if I say k create namespace, okay, and okay, sorry, namespace, my namespace, then it says it has created it, and I say get namespaces. My namespace is here. Now, if I want to say get pods to see what's running. So whenever you want to see what's running, you always use k kubectl get pods, or kubectl get service, or kubectl get deployments. So you will always see, when you want to know something, you always use kubectl get. So get is your thing. So get pods, get svc, get deploy, get namespaces. That's what you will use. Now, one thing to be aware about, when I say k get deploy, k get service, k get pods, it is not bringing the pods from any of this. It is by default automatically bringing it from this namespace. Let's say I want to get all the deployments from all the namespaces. These are the total number of deployments running on all the namespaces. It's saying, I can make it bigger. Okay, it's saying in this namespace argocd, these are the deployments which are running. In default, this is a deployment which is running. Ingress, this is a deploy it's running. And these many things, these are deployments it's running. I can do the same thing with pods. Even in pods, it will be even more. -a flag means find, give me this information from all the places. So not saying these are the number of pods running in all of these things, but I simply say k get pods -a, sorry, k pods, then it will only give me the pods running in the default, which is this many, these many only. Okay, guys, stop me in between if you're not really getting. If I want to say I want to know get pods only from, let's say, argocd, then I say name pods argocd. So it will give me the pods from the argocd itself. Okay, right? So this is how you switch between namespaces and do things. Okay. Next thing, next thing. Let me do a clear quickly. Okay, next thing here is context. So you need to understand the context. Okay, let me open diagram here. Now, it never really happens that you will always work in one cluster, right? There can be multiple clusters in your which you want to manage. So, for example, there can be one cluster. Let's say you have one cluster. Can I now copy paste? Okay, got it. What's the problem? Anyway, can't fix it now. Okay, so if you want to say I have cluster 1, so I have K8's cluster 1. See, when I say cluster means it's a cluster means two things basically. One is I have some machine and on top of it I have a Kubernetes cluster. So in all I say Kubernetes cluster. So I have cluster 1, then I have cluster 2, Kubernetes cluster 2, and then I have, let's say, Kubernetes cluster 3. Okay, and then you have your machine, right? So where is my developer? My developer is here, which of course I can copy paste. I know, fine. So if I say I have a developer, which is I'll borrow him for a while. So if this is a developer and he is on his personal machine, which is, let's say, he already have a machine, sorry, and on his machine he have this kubectl installation done, right? So he have this kubectl client available on his local machine. Now when he runs kubectl get pods, how does kubectl know which cluster to point to? Should it point here? Should it point here? Or should it point here? Right? How this cluster would know that? Right? So that configuration comes under this thing called as context. So we need to educate kubectl on which context or which cluster to point to, right? How to do that? Let's open my command prompt now. Okay. Let me make it smaller. Let me make it smaller again. Okay. Now this is the situation. So I need to make sure that I educate my kubectl client on which cluster to go to. So I say k current. Okay. K current context. When I say get current current context. Okay. Oh, sorry. So I have to say k config because I have to say config, right? So I say k config current context is saying the current context is minikube. Okay. Sometimes we forget the command, right? So whenever you forget the command in kubectl, don't worry, don't go to internet directly to know what it is. Rather, you just say k and you say config, right? And you say -h. So it tells you the details about that command. Okay. So you say k config -h and you say help, and then this is where you will, guys, can you hear me?
Yes.
Okay, thanks. So you go k config h and it tells you what are the commands you have and what those commands really do. So current contact, display the current contact, delete cluster, delete, don't do these things. Then delete user, get clusters, get contacts, get user, all those things you can try doing here. Primarily, what you will primarily use is current context to know where you are and maybe use context. This is how you switch the context, right? Switching context here mean that this is context 1, this is context 2, this is context 3. When you say switch context, if kubectl is right now pointing to this cluster and you change the context from this to this, then you say kubectl config use context new context name. So for example, how many contexts do I have? Let's see that. So if I say you say get clusters, describe one or more contexts. So I say kubectl config get contexts. It's telling me these are the contexts it has for me to play around with. Okay, let me do a clear. Now, if I want to change a context, I will simply say okay, if I want to change the context, then I will say kconfig -h, again go to help, and then use context, and context will be switched. For now, you don't have to worry, because you will always, right now, because you're all learning, you will always have one context, which is your minikube or microcads or kind or whatever it is. So you don't have to worry too much about it. Okay, the information about this context is present actually inside a file called as kubeconfig file, and you can see that somewhere again in a similar location. If I say kind, okay, why can't I find it? Cube. Okay, so inside that you will have something like this, where you have all information about the cluster and token and this and that. So I don't want to show this information because I handle multiple clusters from here. So I don't want, don't want to show those things. Okay, so that's how you basically you change context. That's why you use different context and all those things, right? Okay, for now there is just one context, so you don't have to worry too much about it, right? And if you want to change the context, just in case, you run the command config use context, and you say minikube is the name of the context, and it says okay, switch to minikube. Okay. Okay, what's next, right? So the next thing is, if I go back to k get deployments, I get one deployment, and let's say I don't want to have this deployment, right? So how to remove things? So I'm now telling you how to remove existing things which you have. So I say k delete and the name, and this will just remove the deployment. Okay, so I have to say what type I am deleting. So I have to say deploy and delete, and it says it has deleted. Now if I say get deploy, I find nothing. You see, by default, if I'm not specifying a namespace, it will always go and find this into a default namespace. Default namespace is what I showed you earlier, which is k get namespaces. This is the default one. This is the default one. This is where it does everything. Now, if I say get deploy, sorry, get pods, then I have this pod running here. I don't want this, so I will say k delete pod, and this will go and delete the pods. Okay, po and pod both works, deployments and deploy both works, service and svc both works. They are also provided the short forms, right? So if I say k get pods, it give me detail. If I say k get po, then also it works. If I say k get service, then also it works. If I say k get svc, then also it works. If I say k get deployments, it works. If I say k get deploy, then also it works. So short forms work. So you see, if I had to write Kubernetes, sorry, if I had to write kubectl get deployments, is so many keystrokes. So instead of doing that, I simply saying k get deploy, less keys, but still quick result, right? So these are the shortcuts which they have provided. This is something which I have not configured. K, from converting kubectl to k, that I have done in my bash profile, but these things deploy to deploy or svc, service to svc, these are all shortcuts given to you by kubectl itself or Kubernetes itself. Okay, now I want to delete further. I say I want to k get I have no deployments. I want to say k get svc, and let's say I want to deploy few things. I don't want to have these two deployments here, right? So if I go back and say k delete svc name of the service, it deletes it. If I say I want to delete this one, k delete svc, it deletes it. Now let's see again. Let's see the status. What's happening? K get pods, nothing. K get service. I have one service called as Kubernetes, but I'll leave it as it is. Nothing to worry there. K get deploy. Nothing there. Okay, now so far so good, everyone. Understood? I've told you two very basic commands: get and delete. So how to get information and how to delete the information. Any questions so far?
No, sir.
Okay. Now let's start deploying. Okay, so that's where the true power of Kubernetes comes into picture. Let me open my Visual Studio Code. Okay, so okay, these are the kind. I don't want to show you kind. Do I have something already open? Okay, let me remove the kind one and let me bring this one here. Okay, so close all, clear. Okay, so I was trying to create these tutorials for you guys so that you can know, you can try to do this step by step or one after another, right? So this is what I was trying to do. Let me make a change, small change first. So I have divided this into folders. Let's say this is our experiment one. Experiment one, we are trying to do two things. Okay, let me tell you what is a manifest file. So Kubernetes is a software which has sort of, so far we have discussed two components. One is how to access Kubernetes, right? How to instruct Kubernetes what to do. So one thing is kubectl. So you will use kubectl to interact with the Kubernetes. The next thing is to give specifications, information to Kubernetes on what to do. Because Kubernetes is essentially a software which runs your containers. Your application is present inside those containers, and kubectl is a container orchestration, right? So when it comes to container orchestration, you need to tell Kubernetes what is it which it needs to run. What is the pod, how many pods, what is the application which needs to run in those pods, right? So all that information is something which you need to tell. Let me make it bigger, right? So here, what are we telling? Here we are saying this is my YAML file, and Kubernetes understands YAML file. It understands JSON file, but YAML is a more enterprise level format, and that's what we are going to be using as well. So YAML, and I think you already seen YAML in GitLab. That's what we have been using. In GitLab, we are using YAML a lot. So YAML is what we are, how we write the specification of what is to be installed on a Kubernetes cluster, right? Kubernetes has things called as resources. We call it resource. हम resource कहते हैं उसको. जो भी हम Kubernetes में डालते हैं, it is called as resources or called as objects, right? Everything in Kubernetes is a sort of an object. An object always has a kind, a special kind or category or class of the object. That is what we first of all specify. So when I specify the file description, I say this file description is of a special type called as kind pod. So मैं यहाँ पर pod declare कर रहा हूँ. I'm declaring a pod here, right? A pod is a basic fundamental unit of where your application runs, right? If you remember, this is what the pod is, जो हम पहले देख रहे थे. If you remember, this is the pod. Inside pod, you run container, right? So that's the two basic information you have to provide, right? So name of the pod and what you will run inside the pod. So spec here means specifications, right? Inside specification, you have an object called as container. Inside that, you can define how many container you want to run it. So this is how you see you can run multiple container inside the same pod. It's not advisable, but you can still do it, because if you see under container, you are having a list. So in YAML, if you don't know this already, this symbol indicates it is a list, right? So under container object, you have list of objects. So this whole thing is called as an object, and this is a list of objects. So you can have multiple lists inside, but it's not advisable. So we simply say we want to create a pod whose name is my-flask-api-with-pod. So I've given it a name like this. This is not good name, but just to explain this, I've given this name with the pod, and I have a next example to show you with deployment, where I want to tell you what's the difference between deployment and what's the difference between pods. So that's the reason I have given it a name as my-flask-api-with-pod. I have given it some labels. Label is just for tagging. It has a wider use case in the because that's how different objects link with each other. So if I want to say I want to link this with a service, I need to give that service the name of the labels, right? So we'll discuss about how labeling works. For now, to keep it very, very simple, wherever there is a metadata or name coming up, you try to give it the same name for now, so that you don't mess things up and things will stop working and you say it's not working. To avoid all these situations, don't play around too much with labels, otherwise things will start breaking. Of course, if you learn more, then you can play around with this. But the idea of label is this. So this is the name of the whole resource, and this is the label I have given this. Inside that, I have a spec. Spec means specification. That means what container I want to run inside. So I have a container. Then I'm giving the name of the container, and then I'm providing the image. This is very similar to when you say Docker run it, right? So it is saying exactly this. So this part is very similar to this part. Okay. Fine. This pod is very simple. I doubt anyone would have any question here. Understood, right? How I'm specifying a pod?
Yes, sir.
Okay. Service. Next thing is service, because if I go back, you cannot access a pod without a service, because pod you don't get to see any IP. You get to see IP of a service primarily, right? Of course, internally everything is networked, so everything has IPs and all those things. But in the logical structuring of things in Kubernetes, service has IP, and you attach a pod with a service, and that attachment is done via something called as labels. But that part, as I said, we'll discuss later. Okay, now I have API version as v1. Kind is service, right? So as I said, in Kubernetes, everything is a object. How many kinds of objects we have? Primarily, the things which you're going to be seeing a lot, you will have pods, you will have a pod, you have a deployment, you have a service. These three things you're going to be using a lot, but there are more. There is ingress, there is config map, there are secrets, there are users, user groups. There are many such resources available, but for now we are going to be looking into only these kind of things: pod, deployment, service. So kind is pod, here the kind is service. Here same, when I say metadata means the data about the data, right? That is the real meaning of metadata. So I'm giving under this, I can provide some labels, I can give it a name. So I'm saying this object's name is my Flask API with pod. Then I'm saying the specification. I'm saying the selector. Selector means what pod it will select, right? So I have to give it a similar name, which I'm given here at the top. And as I said, for now, if this looks a bit confusing, don't worry. Try to give the same name everywhere. Later we see what is the real implication. Right now, just give the same name everywhere, so that okay, you get to see, so that it works for you. Okay. And in the ports, I'm saying whatever traffic which is going to come to this service on 5000 port, transfer it to the 5000 port of the container. Why I'm saying 5000? Because my API container runs on 5000. When I created my API, I exposed 5000. I can show you quickly. The API which I'm running inside now is this one. And here this is my API. This is a Flask API. This runs on 5000 port. So I had to provide this information that my container listens, the application present inside my container listens at port 5000. If it were an Nginx server, I would have said 80, because Nginx by default listens at 80. Okay, so my service is the one which will get an IP, and my service and my pod will be the one where I have an application. The user will reach out to service. The service will route the details back to the pod. Exactly this. service, pod, service, pod. Right? So the traffic will come to service, service will transfer things to pod. Now here I explained this in a block diagram, right? But this is not, block diagram is not understood by Kubernetes. Kubernetes has to be explained in terms of some language, some specification file. And this is what I've done. So this is how, what Kubernetes understands. So if I say Kubernetes, please listen to this file. So we'll say, oh, okay, you want me to create a pod, you want me to give it a name as this, and you want me to spin up a container inside. Okay, I'll do that. Then I'll say, oh, okay, you want a service as well? Fine, then I will go and create a service, and this service has to be linked to the pod which has a label as this, and then the traffic which will going to come on this pod is 5,000. I will listen to 5,000, and then I'll pass it on to the 5,000, which will be sent to the container port. So this is how Kubernetes understands. Now, how to trigger it? By the way, these two can be as separate YAML files, but in YAML, there is a feature that you can combine multiple YAML files within the same file using these 3 hyphen statements. When I do this, they will be, I can place 2 YAML files within the same file. This is not possible in JSON, but this is very well possible in YAML. Okay, and that's the reason I have just one file created here. Okay, now let's go back and open the shell. So I'm opening my shell directly here. Let me delete all the existing ones. And now here I will go and start running my commands. Okay, so my file is present inside manifest experiment1 and the file name, right? So I will go and switch to this drive first. Okay, manifest experiment1. So I am here. You see, I am inside this file, k8s all-in-one -pod.yml. Okay, now let me quickly do a quick check. So do I have a service? No, just one, which is of no interest at the moment. Next, what I have is, do I have a deployment? No. Do I have any running pods? No. Now, when I say k, or in this case, let me do kubectl, so that you get some perspective. Kubectl apply. So kubectl apply, if I say -h, so this is I'm showing you -h again to tell you if you forget a command or arguments about that command, you can use -h as help, and then it will tell you what to do. So apply a configuration to a resource by a file name, right? So I will go back again. I'll say k apply -f. -f means what file, and I want to run this file. So I say apply -f k8s all-in-one -pod. When I run this, it will execute these 2 commands. It's saying I have created a pod with this name, I have created a service with this name. Did it really did that? Let me check. I say get pods. I have a running pod. Previously it wasn't there. Now I have a running pod. Okay. When I say k get service, I have a running service. A running service which has a cluster IP of, which is a value as this, which is not accessible from outside. Why? Because cluster IP is not accessible from outside, right? That's what we learned earlier, cluster IP. So service gets a cluster IP and it's not accessible from outside. It's a cluster virtual IP which is only accessible from within, right? To access this service, I don't need to provide the IP address to a fellow service. I can only provide the name of the service. So name of service would be http://my-flask-api-with-pod is accessible across. So no need to provide the IP. The service name is enough to do that. But right now, there's no other service using that because I just have one service here. Ignore this, please. Don't get confused with this. Ignore this. I just have one service available at the moment. Okay, so I have a running service. I have a running pod. Okay, now let's learn to investigate. Let's learn to investigate what's happening. Okay. So to do that, there are different commands. Okay, if I say get pods again, I get a pod. What if I want to see what container is running inside my pod, right? I want to say what is really the content of this, right? Can anyone tell me how to check what container is running? The people who have done this before.
-o wild use करते हैं, I think so, not sure.
Okay, so I say get pods -o is the
While
output format, and I say YAML. When I say this, or I can also say JSON, or if I say whatever, then it will tell me what it accepts. So allowed formats are these: JSON, JSON path, JSON, blah, 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 right? So I want to say JSON. O here means output. So if you want to get a content out from this command, if you simply say this, for example, it returns you a table. That's a default. But if you want to get this information in a certain format, then you provide the output format also. So that's the command here. I say name, this is the name of the command. I say JSON, it gives me the detail in the JSON. And inside this JSON, it will tell me all the details about that pods. Okay, so it's telling me what's running here, what are the annotations and container. So this is the container which is running inside. And this is the port which is listening to. What is the volume? Oh, volume is something which I have to explain you. I haven't done that in Docker. Okay, fine, I'll do that later. Then DNS and all the things it is trying to show. What is the conditions, last probe time, blah blah blah, host IP, face, pod IPs, and everything. Okay, so this is how I see what container is running. But if I want to say k get pods, sorry, if I want to see what is let's say the logs, right? So I want to see what's running inside, right? So if I want to see the logs which is getting published inside the container, I say k logs, and I have to copy the name of the pod, and I have to say k logs. So now it's telling me what is being printed inside. If I want to continue to get this, I say k logs, then what was it? I think -f, and name of the pod. Yeah, so now it will continue to show me the results here, but it's of no use because I am not able to access it. So let's see how we can now access it. Let me close this and let me make it bit smaller so that I can tell you something about how to access it. Okay, let me do it here. I'll close this. Okay, now I have one service running, which is this. Now this service is a cluster IP service, right? This service is a cluster IP service, and that means it cannot be accessed outside. There are multiple ways to access it: ingress, port forward, load balancer, node port. I'm going to use a port forward way because that's what I can currently use, because I don't have any other way of doing that at the moment. So I simply say port forward, right? So I say kubectl port forward. Port forward of what? Port forward of my service, which is this. So I say I want to port forward to this service on the port of, let's say, 9,000 to 5,000. Okay, so when I do that, it will start publishing any traffic coming to 9,000 from my local host to the 5,000 port to this, because this is listening at 5,000. So 9,000 is my local. So I go here, I say localhost 9,000. Okay, let me show you the fun part also. Let me open another command here. Okay, here I will go and type the command. Do I already have it? This one, klogs -f my-flask-api, right? So if I do this, it will now look for all the logs. So if I go and hit this, my API is now running, and you see it is saying the traffic is reaching the container. The reason of showing you this is to show that how the traffic is going from my local host. I've done a port forward, so it's going from my local host and going to this service, and this service is transferring the traffic from that service to the pod. And this is the I'm showing the content of the pod, what's happening inside the pod. So klogs -f the log thing, and it's doing it. So if I go back here, I say books 1, it returned the result, and it's saying it has served this request. right? I say book as 3, and there's no books as 3, so it's giving me error, and that's what it's also giving me here, right? So this is how things are working. Things are going from here to the service here, and from service it's going to the container. Okay, any questions so far? Okay, if not, then let me show you another example from here. So this is what I explained to you, which is pod and service. If you don't want to have this, so I go back, I say k get pods. I have one pod, I say k get service, I get one service. I don't want it, so I say k delete -file. So it will go and delete both the things. So I'm not explicitly going and deleting the pod which I did in the first place in the very beginning of this session, but I just went and said whatever this file deployed, delete all those things. So it will go back and see what's there in this sort of file. Okay, one pod was created, one service created. It will check, is it still there? Yes, it's still there. Okay, so let's just delete it. It will go and delete it. If I go back to see service, not there. If I go back to see the pods, not there. Okay, now let's quickly look at another example, which is this one, the deployments part. Now, what is a deployment, right? So deployment is a logical containerization or encapsulation of pods or representation of pods. So when you create a single pod, it will always a single pod basically, right? But what if you want to have different replicas of the same pod? So right now what we did was this case, one service, one pod, one service, one pod. What if you want to have a situation where you have one service but you want to have multiple pods? And then you have to have sort of a load balancing thing so that you can define the desired state of the pod, and then it will create that pod for you, right? So it will spin up those many pods for you to be load balancing, or so that your service can be more performant. So how you do that? So instead of creating a Kubernetes resource type of kind pod, you will go and create a resource of kind deployment, which is very similar to saying I want to create a pod, but now you can define the replicas. So only difference between deployment and pods is that when you create a deployment, you create a replica set as well. So replica set or replicas here simply mean how many pods do you need. Okay, so if I go back here, if I compare this with the pods, it's more of the settings is more or less the same. Here the settings are still almost the same, except one thing, which is the replicas. Okay, so do you have the replicas here? Where you can define how many I need, and service is still the same. So now if I go out of this directory and I say experiment 2, and now here I say kubectl or k apply -f k all-in-one deployment.yml. I get a deployment which is created, I get a service which is created. So effect of this is the same. So if I say get service, if I say k get service, I get a service. If I say k get deploy, I get a deployment. If I say k get pods, I get a pod, because this deployment had made sure that a pod is already present here. Okay, now see the effect of replicas. If I go back here and say replica as 3, and I simply go back and run the same command. So this is the advantage of Kubernetes. That is, you don't have to delete the existing deployment and deploy the new one. You just make a change in the file, and it will identify the changes. So now, since you have made a change in the file saying I want 3 replicas, and if I run the same command k apply -f, so I'm saying I want to apply the new configuration now. So it will say service is unchanged because this was unchanged, nothing changed here, but the deployment there it sensed a change, so it is saying configured. And now if I go back and say get deploy, I'm having 3 containers running, 3 pods running. Earlier it was just 1 out of 1, now it's saying 3 out of 3 is running and 3 are available, all 3 are available. Okay, now if I say get pods, or let me go clear it out. I say k get pods. I get now 3 containers running, right? Let me make it change. I say I want to run 5 containers. So when I say 5 containers and I say apply, configured, get pods, I have 5 containers now. Previously were 3, I have now 5. I would say no, I want to have just 2 now. Then apply, get pods. So you see, because I made a change of 2, the existing 2 containers are now terminating. So this one is terminating, and this pod is terminating, and this pod is terminating, and 2 are still running. If I do a get pods again, it's now saying 2 are running. Okay, so that is the advantage of using a deployment, and it runs exactly same way. So if I say get clear k get svc, and I say k port forward. Okay, I say k port forward. Okay, let me show another fun part. Okay, I can't show that this way. If I go here, okay, I can show you here. So let me open another terminal. I will make it a bit bigger. So now I will do something to show you certain features of when you have 2 replicas. Okay, okay, here. So I have these many command prompts open to see what's happening. Okay. Okay, so in this one, I will say, is this also, let's say, clear? Okay, how many pods do I have? I have k get pods. I have 2 pods. One pod is in, second pod is that, right? So I will now say k logs name of the pod. Okay, -f. Okay, so now the logs are coming here, and then I will say copy this and say k logs -f, and I say this. Okay, and now I will say k get service, and now I'm saying I want to port forward, so I'll say k port forward, name of the service, and I'm saying whatever is coming at 9,000 on my local machine, give it back to 5,000. Okay, so I have to say service svc. Okay, now let's see what happens. If I go back here and I say 9,000, the log, the request has come to this container. So you see what I'm doing? Okay, if you not getting it what I'm doing, let me quickly explain. मेरे पास एक सर्विस है, मेरे पास 2 पॉड हैं. अब मैंने इस सर्विस का पोर्ट फॉरवर्ड कर दिया है, दिस सर्विस का पोर्ट फॉरवर्ड कर दिया. दैट मींस आई एम एक्सेसिंग इट फ्रॉम माय लोकल मशीन. तो यहाँ मैंने पोर्ट फॉरवर्ड कर दिया. सो जो भी मैं अब यहाँ से रन कर रहा हूँ, वो डायरेक्टली ये सर्विस पॉड्स को भेज रही है, पर वो किस पॉड को भेजेगी ये सर्विस खुद डिसाइड करेगी. तो कभी वो इस पॉड को भेजेगी रिक्वेस्ट, कभी वो इस पॉड को भेजेगी. तो मैंने यहाँ पर दोनों पॉड के लॉग्स को खोल के रखा हुआ है ताकि हम सेंस कर पाए किस लॉग किस पॉड पे ट्रैफिक जा रहा है. तो जब मैंने यहाँ पर व्हेन आई डिड दिस, the log, the request went here, it did not went here. Okay, so this is handled by the the service or Kubernetes itself. Okay, I can choose my favorite, but it usually doesn't work. If one pod is busy, then it will start directing it to the new ones. I can set up some sort of strategy. My assumption here was that it will do a round robin, which I think it's not doing. It is directing it directly to one pod itself. Only this pod it's running. So I have these 2 pods. One is this one, and second is this one. One is this one, second is this one. If I do it very quickly, okay, if I say books, Please go there as well. Okay, it's not going. All requests coming to just one pod. Okay, so this, I think what's happening inside is, by my best guess, is it's not really doing round robin at the moment. Maybe once if it's busy, then it will start routing it to other. Right now, only one pod is catering to my request. Usually, if I think configure it good, then it will start doing round robin. Right now, it's sending it to one pod only. But I wanted to show you like one time, sometimes request going here, second time request going here, but right now I'm not able to show. But they both are active. That means if somehow this pod is not able to reply, then my application doesn't go down. The request will then go to this pod. Okay. Any questions so far? Okay. If not, then I have just one more thing to talk about. I was thinking we'll have a lot of questions today, but I think we don't have. The same situation happened when I was explaining Terraform. Everyone was like literally silent. So I'm thinking, I think this is a bit overwhelming for a few of you, which is good. That means you will have to go and give it a try. You have to start your hands-on. Now, I will introduce a tool here so that you can manage these things better. So there is a tool called as Lens. Okay, so it looks like this. And from here I can manage my cluster, so I don't have to go and do a lot of things from command line. I can really visualize it. So I'm onto my cluster here, and then here is telling me that I have one node. This is the details of the node which I have. It's an Ubuntu system because everything works on Ubuntu. It has a node IP of this one and all those things telling me. Okay, and what are the pods it's running? It's telling me all these things here. My Flask API, I can go and say my workloads, what are the pods running. So I have this pod running here, this pod running here in the default namespace. These are the namespaces I have. And then I can go inside. Okay, and then I can see the details of it. Then I can also go to logs. The logs will tell me what are the logs running. Then I can also go to shell. So I can, do a shell command inside. What? It's trying to connect. So this Lens tool is quite good, but you cannot use it if you're not using your local system. Then you cannot. But if you're using local system, I would recommend Lens. It's a free software which you can use to see what deployments are running, what are the services you are running, and all the other things. Services. It's telling you services. It's a cluster IP. So this is exactly what you were also seeing when you were running things from command line. Nothing is different. So very similar to Docker desktop, right? You're running things in Docker, but all the things which you're running from Docker is also coming in Docker desktop. The same thing is happening here. It is a graphical interface of the state of the Kubernetes resources and everything you can manage directly from Lens. Okay, I can tell more commands, but looking like you guys may not be following it. I don't know, so maybe I will not continue with more commands. Rather, I'll wait for your questions. Let's give some time for questions, guys. Tell me what is it which you understood and what is it which you didn't understand.